Yeah, I see that.
And the only
Going
numbers that are different is it counts down, not up. So it actually goes from 38 there
35.
to 35 there.
It changes the look of the graph too. It becomes left hand.
It does, and notice that left hand will overestimate these as opposed to right hand. So you can't always say whether left hand or right hand overestimates. It depends on the shape of the slope of the graph, really. So let's see, that's 38, that's 35, that's 34, that's 31, and that's 27. So delta t is what?
That's 3 because it's just a change in base.
T sub 0 is what?
38, I think.
Uh-huh.
T1 is 3 times
35. Just 35.
Oh, okay.
Remember, they're talking t's are this.
Oh, yeah, that number, the base, or the height number. So then T2 is just 34?
Uh-huh.
And then 31 and 27.
Yeah.
Oh, so now it's asking.
Now it's asking what the function of T0 is.
So, would we do 3 times 38?
These are all wrong. These should be 0, 3, 6, 9, and 12. And these should be 38, 35, 34, 31, and 27. Okay, shall we submit that just to make sure?
Yeah. Oh, okay, so why did we have it wrong the first time?
Gun shy on these computer problems.
Yeah.
Because it was asking about T sub 0. Well, T sub 0 is this. T sub 1 is that. In other words, on my graph, this is T sub 1. This is T sub 0. This is T sub 2.
So for the F1s, it's like F of T sub 0. I would have thought that I'd multiply and like find the area under the curve for each of those rectangles.
Depending, yeah, we're going to get to that. Find the left and right sums using n equals 4. Well, the left sum is going to be that. So give me what the left sum is going to be. Here, let me
0 times 38.
Yeah, let me put these values here. So 3 times 38, okay.
3 times 38, 3 times 35, 3 times 34. No, wait. Would we use 38 since we're doing left hand?
Remember, start your process off by going to the left point. That's how I begin if I'm using left hand.
Okay, so then 3 times.
In other words, the way to really look at this, if you really want to understand this a little bit better, is draw an imaginary function through those points.
Okay.
Now, if you wanted the area under that curve and you use left hand, my first rectangle has got to start there.
I guess I'm just confused. How can you tell it's left hand or right hand? How do you know that's left hand?
Because it's the left side of that triangle. If I'm going to use right hand, the first rectangle is 0. Because I'm using right hand. In other words, the first rectangle is a straight line, but the second rectangle uses the second right hand endpoint right there.
Mm-hmm.
So that's the difference. So don't be confused if you have a rectangle with 0 height. You'll notice on that first one we did. When we used the right-hand endpoints, this final rectangle had no height to it because it was stopped. In other words, I used the right-hand endpoint to draw the top of my rectangle right there.
Okay, so the left-hand sum, and now we just do 3 times 31 for the last one.
Right. What's that number equal to when you add them all up? You could just add the 4 numbers on the right and multiply the whole thing by 3.
Really?
That's 138. So the numbers on the right.
Answer? Oh.
414 should be right.
Yeah.
Is that what you get?
Yeah.
Is that going to overestimate or underestimate?
Over.
Okay. So the next number we get should be smaller. Now we already know how to do the next one.
So it's going to be,
the sum
first one's a 0.
Yeah,
the sum of those 3.
Well, hold on.
And then the 3 times 27.
Yeah. In other words, we don't lose a rectangle completely. When we do the right method, yeah, we do lose that first rectangle, but we end up with a second one. So the right one is those 3, and the last one still has height. So yes, plus 3 times 27, which is going to take away 33 from this number.
81.
381?
No, instead. Yeah, 381. Yeah, you're right. Okay.
Use n equals 2. Delta t is what? Remember delta t was 3 when we used n equal 4. So yeah, delta t is going to be 6. What's t sub 0?
Be 0, 6, and 12. Yeah.
F
So then I guess
0.
38, 34, 27.
And left hand is going to be what?
Using 2 subdivisions, it would be 6 times 38. Using left hand.
Yep. So
6 times 38
plus...
And then 6 times 27.
Why not 34?
No, 31, 31. Or wait, why 30?
34. Because t sub 1 is 34. Remember at the top of this page, they told us the formula for doing it right there. When we're using left hand, we're going to use t sub 1. When we use right hand, we're going to use t sub 2. So left hand, we're using t sub 2, and f of t sub 2 is 34. So 6 times 34, that should be 6 times 72, 432.
Yeah, that's what I got.
And the right hand end method.
How would we draw this?
Well, you tell me.
Draw the line at 34 to 6.
First of all, look at t sub 2. Go up to the only value we have. That's the right side of that rectangle we're going to fill.
Yeah. Yeah, that's what I meant. Draw the line from 34 to 6.
Yeah, and then the other one goes from 27 to 6. So it's 6 times 34 plus 6 times 27. That's 6 times 61. That's 366. Okay, the only prediction I made that was wrong was it's going to take us more than an hour to cover these 10 problems.
Yeah, that's not a problem. I should probably be able to do the rest on my own.
Yeah, I would think once you get the hang of it. These are all pretty much similar. It's not like the last couple sessions. Still been trying to find an answer to that one. I think I made progress, but it's too late now anyway. So, all right. So the velocity.
Wait, which one?
4.8.
Wait, I figured it out. Are we talking about number 1?
Yeah.
What did we do wrong? I figured it out.
Okay. Well,
You had to. Yeah, I'll talk about it later.
Yeah, we probably don't want to, since we're on short time here anyway, we probably ought to get on with these. But I'm glad you figured it out. That's good. Okay, so delta t is 0.2. That means we're breaking up the x-axis into 5 intervals, correct?
Mm-hmm.
Okay, find an overestimate and an underestimate, then average the two. Well,
Okay.
finding an overestimate, I don't know what this curve looks like right away. So I'm not sure whether it's going to be an overestimate or an underestimate yet. But when we find, just find for both, whichever number is bigger, we'll put it in the overestimate and then the underestimate. Okay, so if this graph looks hyperbolic in nature, we'll draw it like that. Time equals 0. Where does that graph cross the y-axis?
I have no idea.
Well, plug in 0 for t.
5. So 2/5.
2/5. And this is going to only get smaller. At 2/10, you're going to have to use your calculator on these, I suppose.
So at 0.2.
So this would be f of 0. So let's list these. F of 0 equals 2/5. F of 0.2 equals what on your calculator?
5 plus 0.2. 2 divided by 5.2. 0.38. So then 0.4 is 0.37. 0.36.
No, 0.6? Oh, really? Bug slows down at a very slow pace.
And then 0.8 is 0.34. And then 1.
We're going to need that for the left-hand end method.
And this is 2/6.
How much?
2/6.
Oh, 0.33, right?
Yeah.
Okay, so for one method, we're going to take the, let's look at the first method. Since these are all getting smaller, that helps. In other words, I can draw my graph kind of like that. Pretend that there are 1, 2, 3, 4, 5. We need a 6th interval. So let's start with that. Here's the first dot. So for the left-hand end method, what is my sum going to be?
Well,
What's the first rectangle going to be?
it'd be 0.2 times 2/5.
Yeah, let's call that 0.2 times 0.4. Okay.
And then
Go
0.2
ahead.
times 0.38.
Okay.
0.2 times 0.37. 0.2 times 0.36. And then 0.2 times 0.34. I think that is.
And there's only 5 intervals. I don't know why I put that extra dot in there. Let me take it out.
So now I just
Add these numbers up with this one and multiply the whole thing by 0.2 and you'll get your answer.
so plus 0.37 plus 0.36. Okay, and then times 0.2.
Mm-hmm.
I got 0.3.
Did you add the 0.34?
Yeah.
So you added the 5 numbers.
0.4 plus 0.38 plus 0.37 plus 0.36 plus 0.34.
Okay.
Times 0.2 equals 0.37.
Is that the over? No, it doesn't. Okay, yes it does. Is that going to be an over or an underestimate?
I don't know.
Well, look at the
I have to
chart.
figure out the other one.
No, we don't really have to. Let's just look at that.
That'd be an overestimate.
Right. In other words, whenever it's going down, it's going to overestimate it, the left-hand endpoint. So we can go ahead and put that number in there. What was it?
0.37.
Do they want it to 2 decimals?
Yeah, I think.
Should we check that? For each include units. Boy, they just like to mix it up, don't they?
So meters an hour, so M. Yeah.
Is M okay?
Yeah.
Should we check that before we go further?
Yeah.
I can go backwards, right, to do the underestimate?
Uh-huh.
Incorrect.
Were we supposed to just plug in 0.2 and 0.4 and get our own points?
Yeah, in other words, they have given us a function here instead of just a table of points. But
So we had to find the
notice
point.
that both the tables we looked at in the previous 2 problems were velocity. It was all about velocity. So, in other words, we come up with our T0, our T1, and our F of T0 and F of T1. And that's what I did up here, as I came up with all of those. Now, it's possible that we have a round-off error here. In other words, I'm sure these weren't all smooth. I'll bet you do have a round-off error.
Alright.
For one thing, this last, we didn't use this last point because we're using left-hand method.
I rounded most of those, too.
Well,
So
let's try not rounding them. Let's go ahead and, yeah, get the first 5.
So 5 divided by, or no, 2 divided by 5.2. 0.3846.
Hold on. 0.3846, okay? Yeah, already I can tell that our number is going to be bigger than what we put here. I'd almost like to put 0.38 and keep trying until it's right.
So then 2 divided by 5.4, 0.37037. 37037.
Okay.
2 divided by 5.6, 0.357. 2 divided by 5.8, 0.3448.
And what's the last one, just so we'll have it? Oh, we know what that one is. 333.
Okay.
That's 1/3. 2/6. Yeah. Okay. Now add these first.
Add those and no, add the 2/5 too, right? For the left hand.
Which one did I miss? Oh, the 0.4. Yes, yes, yes.
So all right. So add all those up.
Add not all of them, just the first 5.
Yeah. 3846. All right, I got 0.371354.
After you multiplied it by 0.2?
Yeah.
You got 0.371?
354. I don't think that's right. We can try it. 1354.
Surely they don't want it more than 4 places. Could it be we have to spell out meter?
No, because it tells you if the units are wrong.
Oh.
It says your units are incorrect. But I know it's meters.
Amazing.
That's weird.
That's terrible. It really is terrible. First of all,
like online homework.
well, it's terribly demoralizing, first of all. Because they've asked you to do all this crap in the first place, adding up all these little digits. They don't tell you that you need 4 decimal places for another.
Yeah.
All right, so now that we have our numbers, the right hand, you should be able to see by now, is going to be the sum of those 5 numbers multiplied by 0.2.
All right, it's 0.358. No, yeah, underestimate.
That's only 3 decimals.
And 0.14, I guess.
Well, just 0.
Yeah, and meters. Plus 0.3713 divided by 2. 0.36465. 465.
So is that 4.7 or 4.6?
And it's 0.36465. Isn't 65?
36465. So is the 4th digit a 7 or a 6?
Yeah, 7 rounded.
Got to round it up, I think. Yeah.
All right. I think we can do one more.
Yeah.
Find the exact distance traveled.
Oh, finally. Finally we get the algebra. Velocity of, calculus. Not that the other isn't, but the other is only to get you to understand what you're doing, what's going on. So how am I going to do this one?
Is f of t equals 10t. Use a graph to find the exact distance traveled from 0 to 10. So we would draw our graph and then we just plug in 0 through 10 for t to get our points.
Yeah, 10t is basically a straight line.
Yeah, basically.
Okay, so there's 10 seconds. There's 0 seconds. What's his velocity at the end of 10 seconds? 100?
Yeah, 100.
So what's the area of that triangle?
1 sec. Alright. Then the area, 1/2 base times height, so 10 times 100 divided by 2, right?
Uh-huh.
500?
Yeah, now, if we wanted to do this by calculus, it would be the integral from 0 to 10 of this function. dt. There's the calculus method of doing it. In other words, we can still use geometry there because they gave us a linear velocity function. But
could I solve that integral?
Sure, let's do it. It's 10t squared over 2, which is t squared over 5t squared, evaluated from 0 to 10. Well, when you plug in 10, you get 500. When you plug in 0, you get 0. So,
how did you get 5t squared? Oh, no, yeah, how did you get 5t squared?
Power rule. Take the antiderivative of 10t. In other words, you add 1 to the exponent, divide by the new exponent.
So to find an integral, you always take the antiderivative?
Yes.
I forget derivatives. We haven't actually started integrating yet.
Really? Wow.
Unless we have and I just missed it on Friday.
No, you probably have not. It's just that by some of the material you've told me about in the previous couple sessions, I thought you were way ahead of me, but it doesn't sound like you are.
Yeah, I think
it's just that they were different. They were unique problems that I hadn't encountered before, I suppose. But yeah, no, this is how you do. In other words, we could do this one using geometry because it was all straight lines. But put a curve in there, finding the area under that curve, if you know that function, then this is the way to do it, is to use integration. That's what the definition of integration is the area under a curve.
All right, let's try and get one more problem.
Okay.
I'll submit that one.
Did we check that one?
No.
Shall we go? Can I back up and submit it?
Yeah, click previous. Yeah, 500 meters. Okay. Decreases throughout the 10 seconds.
Yeah, in other words, they're saying there's a curve here. There is a function, but we don't have the full function again. They haven't given us the function like they did on the previous problem. They gave us the function, it was 10t. Well, here we just know the velocity, the speed, at various points again. So this is another one where we have to set up and divide time into 2-second intervals. In other words, I think you can do this one. Let's just talk about it. The speed is dropping from 115 to, at 2 seconds, down to 80. So that point is on there. At 4 seconds, down to 50. That point is on there. 6 seconds, down to 25.
All right, I got it.
8 seconds, down to 15. So we have this point, this point, and this point.
So they just want us to make our own subdivisions for n this time?
Yeah. When it says what is the best estimate, I would do note the best estimate is probably not the over or under, but average them, just like it asked us to do before. So do this the same way we've done the others. Come up with an over and an estimate. In other words, the over is going to be the left endpoint, starting from there. The under would be the right endpoint. Now, the only thing that can be confusing when you do the right endpoint on these that go down is you don't have the first rectangle. The first right endpoint is that one right there. And you don't even have the last one. In other words, that's going to be when you used right endpoint, and then the last one is just going to be a straight line. So left will give you an overestimate, right will give you an underestimate. And when you use the right one, you're only going to end up with 4 rectangles. When you use the left one, you're going to end up with 5 rectangles. You see why? Notice that when I use the left,
so I got the left-hand sum just now.
There's the left.
All right. Got them both.
Okay, averaging.
So I got 1820.
Meter feet.
Feet, I think, yeah.
The skunk's 400 feet ahead. That's not a good sign. Well, let's submit that first. Make sure we got the right number. No.
All right, I did something wrong then.
Just tell me what your math was.
So the left hand I did 2 times 115, 2 times 80, 2 times 50, 2 times 25, and 2 times 15. 25.
Add up that column of numbers right there.
Times 2. So yeah, I got 570.
Where'd you come up with 1820?
Are we only, I thought we were doing the left hand and the right hand and averaging.
Okay, but if you got the average, can't possibly be that.
Yeah, I don't know what I did.
What'd you get for left hand? What's this number again?
Oh, I think I did, try 455. I think I actually hit times 2 instead of divided by 2. 455 feet.
Good. Good save.
Okay, yeah. I just multiply it by 2.
Because otherwise we were going to have to go through all of it. So which of the following statements can you justify? The black box, the skunk may or may not have been hit. I think the skunk got hit. If it was 400 feet ahead, now there's no way you're going to stop, maybe 430, 440, but certainly not 400. Incorrect.
So I think it's in the skunk may or may not have been hit, huh?
The black dot box data is the car stopped before getting to the skunk. Well, that can't be. Unless I'm
that doesn't make sense.
No, so the only other answer can be this. This is kind of a gift, I guess, huh? I mean, if you get 20 tries.
All right.
I hate that answer. First of all, the black box data is inconclusive. That's not a conclusion you can come to.
That makes no sense.
You could maybe say the skunk may or may not be hit, but they've screwed up somewhere on this. Anyway, sorry, but I'm going to have to run.
That's all good. I can.
Because I have my 11. But okay, good.
I'll make the next one
you can get through these, and okay, that sounds good.
All right. Thanks a lot.
All right. Talk to you tomorrow. Bye bye.